Now today we're going to be working on proving identities, and proving identities is by far one of the most challenging problem to solve in trigonometry, and mastery of your identities is basically one of the important skills that you need to have to be able to work out problems involving proving identities. And also since in this particular skill you need mastery of your algebra skills, so working with rational expressions and also factoring will greatly help you in solving problems in proving identities. So let's go ahead and start our identities or proving identities using problem number 1. So in number 1 we have secant x So we need to, of course, the basic rule is to simplify the more complicated side of the equation. And in this case, it's obvious that this side is the more complicated expression or side of the equation. So we're going to work this out by changing all the inverse function to its sine and cosine inverse. So secant is 1 over cosine x, sine x all over cosine x, and sine x. And in this case we can simplify this, so we have 1 over cosine x minus sine squared x all over cosine x, because by multiplying this, sine times sine is sine squared x and cosine x times 1 is cosine x. And now we have a fraction with the same denominator, and just to bring you back to algebra, if you have a over b minus c all over b, by combining them it's simply a minus c all over b. So we're going to use the same concept, and we'll have 1 minus sine squared x all over cosine x, and we know that 1 minus sine squared x is an identity which is equal to cosine squared x, and by cancelling the common term we are left with cosine x. Now the left side or the other side of our equation is 1 over secant x, which is obviously not identical to cosine x, but we know that the inverse of cosine x is 1 over secant x, so we can modify this into 1 over secant x equal to the other side. And now we've finished our proof. So that's problem number 1. And for problem number 2 we'll have 1 plus cosine x equals cosecant x plus cotangent x. So in this case I'm going to simplify this side of the equation. So in simplifying this, I can separate the fractions since I have a single denominator, so I'll have 1 over sine x plus cosine x all over sine x. And by separating them, I know that 1 over sine x is cosecant x, and cosine x over sine x is cotangent x. And by doing so, I was able to prove the identity because the left side is identical to the other side. It's cotangent x. So we're done with problem number 2. And for problem number 3 we have a complicated or a more complex fraction on this side of the equation. So number 3 we'll have secant theta sine theta all over tangent theta plus cotangent theta equals sine squared theta. So in this case what I am going to do is simplify the denominator and see what I can do with the numerator afterwards. So tangent theta, tangent is sine over cosine, and cotangent is cosine all over sine, since we know that they are the inverse of each other. So this are basically their sine and cosine version. So by using this rational expression in algebra, if I have a over b plus c over d, simplifying them is simply a times d plus b times c all over b times d. So I can combine them using this formula in algebra. So we'll have sine squared theta cosine squared theta all over cosine theta times sine theta. And we know that this is an identity which is equal to 1. So now we have 1 over cosine theta sine theta. And this is now our denominator. So what I'm going to do is I'm going to simplify it with the numerator. So the numerator is secant theta sine theta divided by this, which is 1 all over cosine theta times sine theta. And we know that in dividing fraction, all we have to do is to copy the numerator, which is secant theta times sine theta, and multiply it with the reciprocal of the denominator. So it's going to be 1 over cosine sine. So it's going to be cosine theta sine theta all over 1. And from this identity, we know that we can change secant to its identity or inverse, which is 1 over cosine theta. Again, s is to c, c is to s. So secant is cosine and sine is going to be cosecant. So this is sine theta, cosine theta, and sine theta. And in this case, we can cancel this too. And we are left with sine, which we can combine by multiplication. So we have sine squared theta, which happens to be the same as the left side of our equations or right side of our equation. So you have sine squared theta, and we're able to prove that they are the identity of each other, or they're the same or equal. And for problem number 4, we have secant beta all over cosine beta minus tangent beta all over cotangent beta equals 1. So this one, at least now we know that this is what we're going to be simplifying, because that's the more complicated fraction. So we're going to use the same concept that we did in number 3, adding the two fraction or subtracting the two fraction using the formula. So we'll have secant beta times cotangent beta minus tangent beta times cosine beta all over cosine beta times cotangent beta. So by simplifying the numerator, secant is going to be 1 over cosine, and cotangent is cosine all over sine, minus sine all over cosine times cosine beta all over, we'll just use this as our placeholder, because all I need to do is to simplify this, which will give me 1 over sine beta minus sine beta all over 1. So again, this one is still in fraction form, so I will still further simplify this by adding them or subtracting them together. So I can have 1 times 1 is 1, minus sine times sine is sine squared beta, all over 1 times sine is sine beta. And I know that 1 minus sine squared beta is cosine squared beta, all over sine beta. And now I have a more or a simpler form of my numerator. So this and this are just the same. So by rewriting it, I have cosine squared beta all over sine beta divided by whatever this is, which is cosine beta times cotangent beta. And by simplifying this, I'll copy the numerator, which is cosine squared beta all over sine beta, and multiply it with the reciprocal of this, which is 1 all over cosine beta cotangent beta. And at this point, I can cancel out the cosine, and I'm left with 1 cosine, and this is just 1 over cotangent. So I have, hopefully we're almost finished, this is cosine beta all over sine beta multiplied by 1 over cotangent beta. Now we know that cosine beta over sine beta is cotangent all over this, and by cancellation we're left with 1, which is what the identity is. So we have 1 equals 1, and we're able to prove our identity. So that's problem number 4. So this one is probably the longest among the 4 problems that we did, and let's see if it's going to be the same case on 5, 6, 7, and 8. So let's continue. Let's work with problem number 5. We have cosine squared y minus sine squared y equals 1 minus 2 sine squared y. So cosine squared y minus sine squared y is not an identity, although it looks as if it's the Pythagorean identity equal to 1, but it's not, because this one is addition, and there's no identity that we can replace this with. So what we can do is modify one of the terms. So we know that cosine squared y can be modified into 1 minus sine squared y, and by just copying sine squared y, now we're seeing a common term which we can combine. So we have 1 minus 2 sine squared y, which happens to be the same as this identity. So end of proof. So we're able to prove problem number 5 that easily, because it's a simple identity to solve. For number 6, hopefully this is also as easy as number 5. Cosecant squared x times tangent squared x minus 1 equal to tangent squared x. So let's simplify this by changing cosecant into its inverse, 1 over sine squared x, and tangent is sine squared x all over cosine squared x minus 1, and we're left with 1 over cosine squared x minus 1, which is not equal to tangent squared x. So we're still going to work this out by simplifying this, and since we are subtracting 1 minus cosine squared by 1, let's change 1 into something similar to this fraction, and 1 can also represent, which is equal to 1, but now we have a common denominator, and with the common denominator we can combine this two. So we have 1 minus cosine squared x all over cosine squared x, because they're the same, and we know that 1 minus cosine squared x is sine squared x all over cosine squared x, and by the identity, sine over cosine is tangent squared x, which is the same as this one. So now all we have to do is just to write it and equate it, because they're the same, so we can finish our proof. So that is for problem number 6. And for problem number 7, we have another fraction that most likely we're going to be combining. So for 7, tangent alpha all over secant alpha plus cotangent alpha all over cosecant alpha equals sine alpha plus cosine alpha. And since I'm not too good on writing alpha, I'll just change alpha into an easier variable. I'll just use x. So by combining this, using again a over b plus c over d, we have AD plus CB all over BD. So we have tangent x, cosecant x, cotangent x, secant x. Oh, I'm sorry, that's not what I'm supposed to be doing. So this and this, tangent x times cosecant x plus cotangent x times secant x all over secant x times cosecant x. And again, this is the case wherein I'm going to simplify my numerator first and just ignore my denominator for a little while. So tangent x is sine x all over cosine x times cosecant, which is 1 over s, plus cotangent, which is cosine x all over sine x, times s is to c. And by simplifying it, I have 1 over cosine x plus 1 over sine x. And in this case, I can simplify this into its inverse function, which is secant x plus cosecant x. And this is now my numerator. And back to my denominator, I'm going to divide it by secant x times cosecant x. And since this one is just a single term, I can separate this two into, let's put it up here. So I'll have secant x all over secant x times cosecant x plus cosecant x all over secant x times cosecant x. And now I can cancel out the secant and the cosecant. And I know that the inverse of the inverse of cosecant is sine. So this one is sine x and this one is cosine x, which happens to be the same as this. So we have sine x plus cosine x. But since they're using alpha as a variable, so let's be consistent and just write sine alpha plus cosine alpha equals sine alpha plus cosine alpha. And that is problem number 7. And for the last problem, number 8, we'll have sine x plus cosine x times tan x plus cotangent x equal to secant x plus cosecant x. So in this identity, I'm going to FOIL this out. So I'll have sine times tan plus this plus the product of those two plus the product of this two. And now we have 1, 2, 3, 4 terms. And let's simplify this by changing the inverses into its sine and cosine version. So I have sine x times sine x all over cosine x. And this one is sine x times cosine x all over sine x. And this is cosine x times tan x, sine x all over cosine x plus cosine x times cosine x all over sine x. And by simplifying some of the terms that we could simplify, like this and this two cannot be cancelled out, but we can combine the sine x because this one is all over 1. So sine x times sine x is sine squared x all over cosine x, plus this one is cancelled out, so we have cosine x all over 1, plus this cancels out, so we have sine x all over 1, plus cosine squared x all over sine x. So in this point, or at this point, what I can do is probably combine this by addition and combine this by addition, and let's see what will happen after combining these two fractions. So again, I'm going to use the formula for adding fractions with different denominator. 1 times sine squared x is sine squared x, and cosine times cosine is cosine squared x all over cosine times 1. And we know that this is equal to 1, so I have 1 over cosine x. And if I go further, 1 over cosine x is actually secant x. And on the other side, I'm going to do the same thing. Sine times sine is sine squared x. 1 times this is cosine squared x. 1 times sine x is sine x. And we know that this is also equal to 1. So we have 1 over sine x, which we know 1 over sine x is cosecant x. And of course, we need to add them up. But we don't need to put them together or add them by changing it because it's already looking like this side of the equation. So now we know that secant x plus cosecant x is equal to secant x plus cosecant x. End of our proof. So once again, in solving trig identity, mastery of the basic identities is a must to be able to understand this better, and also your skill on adding, subtracting, multiplying, dividing, rational expression is also going to be important in some identities that you need to prove. So if you've learned something from this video, please like, share, and subscribe to my channel. Thank you.